Okay, so we do an example. Examples of trig equations. Or two equations, just an equation, that's an option. So I'm picking one from some post paper. So we are looking at cos 2x plus 3 sine x minus 2 is equal to 0. So for x, within the range 0 less or equal to x, less or equal to 2 pi. Now when the range is given in radians, you must also give your answer in the radians. If a range is given in degrees, you must also give your answer in degrees. What I call the range is this part. It comes with a question. So you want to solve this. Whenever you have an equation, a trig equation, you find out that one of them, in this case, sine is not squared. The only way sine and cos relate is through this. Now, if sine is not squared, then they cannot relate well. So I go and look for the other part. I must make sure that I change cos to sine. Now here we have cos 2x. The good news is we know that cos A plus B is equal to cos A cos B minus sine A sine B. After that, if A is to be x, B is to be x, then again we'll have cos x minus sine x sine x. X plus x is clearly 2x. Cos x is also cos squared x. Sine x is sine squared x. So what we have? We have that this guy can be written in this form. So we come back here where there is cos 2x. We write cos squared x minus sine squared x and add 3 sine x minus 2. It becomes 0. Now, we want to change every cos to sine because of the sine here, which is not squared. So I change the cos squared using this identity here. I'll solve for cos squared x. So it will be 1 minus sine squared x. Then I have minus sine squared x plus 3 sine x minus 2 is 0. Now, sine x negative, negative sine x squared. Those two are all squared and they're negative, so they will add. I'll get negative 2 sine squared x, then plus 3 sine x minus 1 minus 2, I'll get negative 1 is equal to 0. Now, this has become a quadratic. If I want, I let p to be sine x, so that from here, I'm dealing with negative 2p squared plus 3p minus 1 is 0. So that it's now a quadratic. The product is negative 2 times negative 1, which is 2. The sum is 3. And because that's the case, then we'll have negative 2p squared. So I'm looking for the factors. What would be the factors? Of course, 2 and 1. They must all be positive. Yes, so negative 2p plus 2p plus p minus 1 is 0. So this is 2p negative, so that we remain with p here minus 1 plus a 1 down here, p minus 1 is 0. Now p minus 1 is common, and we remain with negative 2p plus 1 is 0. This will tell us that p is 1 and p is 1 over 2. It was supposed to be negative, but there's a negative 2 dividing, so it has become positive. Now we have two values of p. So what we are saying is sine x is 1 or sine x is half. Now remember on the table there, we could only see 1 for sine on where? On x is equal to 90 degrees, if you check. Now, everything has been given in radian. So we change 90 to radian. How do we change? We multiply by pi over 180. So the 0 goes, 9 there, 1, 9 in 18, 2. This becomes pi over 2. So the x bar that we have here is pi over 2. Now for sine x is equal to half. First, on the table there, or on the triangle, we saw that there was a 30 giving us half in the first quadrant. So we go in the second quadrant and say we have 30 is equal to 180 minus x. And so for x, so x is going to be 180 minus 30, which is 150. Now we need to convert this also to radians. So 0 there goes that, 3 here, 1, 3 in 18, 6. So the other value of x is pi over 6. We still have another one, but only after we convert it to radians. So 0 there, 1, 3 there, 5, 3 in 18, 6. So we'll have 5 pi over 6. So these are the three values that we must submit as our answers. So always mark that. Okay, you can find its cos, which is half. You look for the half in the first quadrant and the fourth quadrant where cos is positive. If it's negative, you go to the second and third quadrant where cos is negative. Find the angles that are corresponding to the theta that you find in the first quadrant. You mark that. Okay, so this is enough on equations. You can relate on the equation that you are solving.
Hello.
Hello?
Hello.
Hello?
On the last part there, I didn't get you.
On how to change from radian to degree, from degrees to radian.
Yeah, on the last two parts, I didn't get you.
Which parts are you going last two parts?
Well, we got pi over 6, and the other one.
Yeah, you're just converting the degrees to radians. Using pi is 1/8. That's all. So if you give me that in degrees and I want it to be in radians, I'll multiply by pi of 1/8. 30 goes there once, 30 goes there many times? 6. So I have pi over 6. That's how you convert to radians from degrees.
Okay.
And if I'm moving from radians to degrees, I will multiply. For example, I'm given pi over 6. I'll change it to degrees. I'll multiply 180 over pi, so that this pi and that pi goes. Then I'm dealing with 180 over 6. This is now in degrees, which will be 30. Okay. So we now must deal with What types of angles? No more angles. Graphs. The first one is a graph of sine. If I have A, sine bx plus c plus d, and they will definitely ask me to state all the properties, meaning the amplitude, which is the modulus of A, which will come out as A, positive A. Period, this is 2 pi divided by B. Phase shift, Bx plus C is equal to 0. And so for X. Vertical shift. Vertical shift is going to be the D which is standing alone. Now for easy sketch, we use what we call the scale, which is period divided by 4. Same properties if f of x is A cos B x plus C plus D. Same properties. After having same properties like that, we can now do an example. So, an example. So we'll do one for sine, one for cos. Then we'll be done with the graphs. Okay. So find the period, the amplitude, and the phase shift of the functions. Of the function f of x is equal to -1 plus 2 cos 2x plus pi over 2. Find the phase shift, the period, and the amplitude. And then, hence or otherwise, sketch the graph of y is equal to f of x in the range 0 less or equal to x less or equal to 2 pi. Okay, so we sketch. So first, before we sketch, we must find the amplitude. We said it's the modulus of that coefficient there, which just becomes 2. Period is 2 pi divided by b, but our b here is 2, so we get pi. Phase shift. The phase shift is 2x plus pi over 2 is 0, so we have 2x is negative pi over 2, so x is negative pi over 4. Vertical shift, this is going to be -1. So we are done with the properties. We have listed the amplitude, the phase shift, the period, and the vertical shift. Then now we find the scale because we want to sketch. So what will be the scale? It will be the period divided by 4. But the period is pi over 4. I mean, the period is pi, then you divide by 4. So it becomes pi over 4 as our scale. How do we use the scale? Or what do we call the scale? We call the scale the spacing. When I write 0, what next number should I write? Is it 90? Is it 70? Is it 10? How do I know? That is where now we use the scale. So we are calling it a scale because the spacings will be that magnitude. So it will be 0 to pi over 4. We add pi over 4. The easiest way of adding is just saying, so I have pi over 4. Now I'll have 2 pi over 4. Then I will have 3 pi over 4. Then I'll have 4 pi over 4. Okay? then I'll have 5 pi over 4, then I'll have 6 pi over 4, I'll have 7 pi over 4, I'll have 8 pi over 4, like that. So after you do that, that's when now you see that where there are evens, they can be simplified. So where I have 2 pi over 4, I can say it's just pi over 2. Where I have 4 pi over 4, it's just pi. Again, where I have 6 pi over 4, that is just 3 pi over 2. Where I have 8 pi over 4, that's just 2 pi, like that. So you have that. Then you now take the amplitude. The amplitude is 2, and then -2. Then you start shifting. Then you start, first thing, you bring in the normal graph of cos. The normal graph of cos passes through the 4 first points. It starts at 0, passes through the first one, comes here, goes up, all the way up to there. This is the normal graph of cos. Now, since we must go all the way up to 2 pi, we'll have the graph come all the way up to 2 pi also. So it will come all the way up to 2 pi. Following the interval, then we shift it now. Okay. Take it anywhere. So you move. Now I want to start moving now. So we are done with the amplitude, done with the period, done with the scale. Now I want to deal with the first shift. So we move to the left by 90. So suppose we put a negative, by 45, we put a negative, for this negative meaning you're moving to the left. So this point that is here, first this one must have moved to there, but this is outside the range given. So we move that one to here, we move this one to here, we move that one to here, that one to there, this one to here, that one you bring it here, that one you bring it there, that one you bring it here, meaning it will have to go down there. Okay, so now you have this kind of a graph. You have this graph, and then so you are done with this. You now push it -1 step. So now you are going to the y-axis now, and say from 2 I subtract a 1, it will be 1. From 0 it will be -1. From -2 it will be -3. And then now you move at the point which is where the one that is here will come to this one. The one that is on -2 comes to -3. From 0 comes to 1. From 2 comes to 1. And from 0 to -1 negative 2 to negative 3. There to negative 1. There to 1. And then to negative 1. Then you draw now. So it will be like that.
So there where you put a red point by negative pi over 4, does it not belong to the red dotted line?
It does, but it's outside the interval given. The question says you must sketch from 0
alright.
to pi.
Okay.
Yes. Okay, so that's how we sketch these types of functions. So this was cos. Okay. Now we sketch one on sine. Hello. Your hand is up. You can ask your question.
So
Okay. Hello.
on the amplitude, does it mean we elevate the graph twice the original distance, or maybe the graph has like move 3 units upwards or downwards?
Not move 3. You stretch it. It's a stretch number.
Like do you stretch it, like let's say for the cosine graph, it starts from 1, then it goes downwards. So do you start from 1 and then you stretch it 2 units downwards, or maybe you start from a point lower than the 1?
You start from 0. From 0, you stretch it all the way up to 2. All the way up the amplitude. Going up, and it must go down after 0 all the way up to negative amplitude. Because the initial one is supposed to be, I put 1, I put negative 1. So it must pass through there if it is sine, and it must pass through there if it is cos. When we stretch this, we are multiplying this number by the amplitude. So if I say 4, then I'll put 4 there and go all the way up to 4 from 0, come down all the way up to 4, again go back. That's how we use the amplitude. Just stating us how far the initial graph goes before it can come down and go to the other.
So it's not like moving, like elevating the graph without.
Stretching.
Thereby the graph for cos, doesn't cos start from 1 going upwards, or since the amplitude is 2, is it not supposed to start from 2 going upwards and then it goes down?
Cos starts from 2 going down.
Not up.
What goes up is sine.
Yes, I know, but then they both start at different points.
What do you mean by O?
Because sine starts at 0, cos starts at 1,
Yes.
and then their graphs go up, not down.
Cos goes down, sine goes up.
But here I understand because it's coming from 2 to -2.
Because how does cos start from 1 and go up to where? There's nowhere to go. So it must come down. Okay, so we do 1 on sine. F of x is equal to 2 sine x minus pi over 3. So let's find the period. Let's find the amplitude. That is 2. The period, that's 2 pi over 1, which is 2 pi. The phase shift, that is x minus pi over 3, is 0. So x is pi over 3. The vertical shift is 0. Then the scale is the period over 4. So the period is 2 pi over 4, which is pi over 2. Then we now sketch. So we're saying to sketch this. Now the question that you have given me is incomplete because it does not say how far x should go. So in this case, I'll just sketch within the first period. So pi over 2. So this is 0, pi over 2, then 2 pi over 2, 3 pi over 2, 4 pi over 2. Then I come back and simplify where there is 2 pi over 2, that is just pi. Where there is 4 pi over 2, that's just 2 pi. Since the shift is to the right, and there is pi over 6, that is the shift. So I'll add to 2 pi, I'll add pi over 3, and the common denominator there is 3, and so I have 6 pi plus pi. So I'll put a point there on the right, scatter for the shift. I'll put 7 pi over 3. So each point here must be moved 7 pi over 3. So, it must be moved. When I come back to the shift, each point must be moved pi over 3 to the right. So the 0, 1 will go to pi over 3. The 91, I must add 90 plus pi over 3. So 6 is the common denominator. I have 3 pi plus 2 pi. So I'll get 5 pi over 6. Okay, I'll get 5 pi over 6. And then again to pi, I add pi over 3. That will be 4 pi over 3. The next one, to 3 pi over 2, I add pi over 3. So I'll have 6. That is 9 pi plus 2 pi. So that will be 11 pi over 6. Okay, so now I have my shifts. Then I sketch. First thing, the amplitude is 2. And lucky enough, there's no vertical shift. So what does that mean? The first graph of sine goes all the way up the amplitude, comes down all the way up to 2 pi. Then we shift it. So we're shifting to the right. So at this point, we're done with that. We're done with the period. We're done with the vertical shift because it's 0. We're done with the scale. So we now move to the first shift. The point that is at 0, we move it to there. That is at 90 to the new coordinate. That's at pi, the new coordinate. There, the new coordinate, another coordinate. And then everything has been done. So we can now draw a solid line. Like that. So that's how we sketch such functions. Like that. Where did I get the period? The period is always 2 pi over b. Now the b is 1. So that's where we got the period. You can use anything to sketch the graph, even a pencil, even a pen. We're not interested in the art of sketching. We're just interested in the critical points and the sketch. The shift always, after knowing that you have a lot of work to do when the shift is not the same as the scale. Because now I have to come back.
Sir,
Hello?
is it important to be showing the original graph?
It's important because that's part of the working.
So even the final answer, I can just leave it the way you've done it. Like the final answer, just leave it on the same graph while written
Yes,
there.
because I'll say this is f of x. Now about the scale. The scale always, you say period over 4 for sine and cos. Now what's the period? We found 2 pi. So you divide it, 2 pi over 4. You get pi over 2. That's your period. From 0 to pi over 2 to pi, 3 pi over 2, 2 pi. Then there's a shift. When x is positive for the first shift, we are shifting to the right. So how far should each point move to the right? It must move pi over 3 steps. The first point is 0. So from 0, it must go to pi over 3. Pi over 3 is 60. So I'm adding 0 plus 60, I'll get pi over 3. Then the point that is at pi over 2 must also move pi over 3 steps to the right. So for me to know where it will be, I take it there. And again, pi I add. 3 pi over 2 I add. If I want, I could have written this as 90, 180, 270, 360. Then I start adding 90 plus 60. First 0 plus 60, then 90 plus 60, 180 plus 60, 270 plus 60, 360 plus 60. Then I convert them to radians because my interval must have been given in radians. If it was given in degrees, I'm just putting these numbers 90 plus 60, 90 plus 60, just like that. That's how we do the shift. So your network is so weak that I cannot get you.
Not interested in the so they're only interested in.
So alternatively, you can write a message if your network is still.
They're only interested in
Okay, so since I cannot get anything, the network is breaking. But since we only have 3 minutes remaining, we should log out and come back for logs and exponentials because we are done.
So
Hello? Hello?
for the scale, why do we divide by 4? Like the period.
Because we are counting the 4 main points from the initial graph of sine. The graph of sine x passes through pi over 2, pi, 3 pi over 2, and 2 pi, and 1 to negative 1. So it goes like this. So we are counting how many important points are there. We have 1, 2, 3, 4. That's how we break every other sign to 4 points. And then let the graph pass through those 4 points. Because the period here is 2 pi.
Thank you.
Okay. So let's log out and log back. We'll come and do logs and exponential.